This video is about the process of heating by convection. We'll be looking at how a system can have energy transferred through it via convection currents. So if we consider a room with a radiator, which is a higher temperature than the rest of the room, then the air around that radiator will begin to increase in temperature. It will be heated by conduction. Once that air is heated, it becomes less dense than the cold air around it. Because it's less dense, it weighs less, and so therefore it will rise. Once it's risen, it is now further away from the source of heating, and so what will happen is it will begin to cool down. Then once the air cools down, it will become more dense. As a result, it weighs more, and so it will sink. Then, once it's sunk, it will push air out of the way, and it will push that air back towards the radiator, at which point the process will repeat itself. In any room with a radiator, there will be a constant current of air like this. The same happens for an ice cube in a room which is warmer than that ice cube. In this case, the air around the ice cube cools down. When this happens, that air becomes more dense, and so therefore it will sink. Once it reaches the bottom of the room, it will begin to increase in temperature again because it is far away from what we call a heat sink. It is far away from the ice cube. As a result, the air will warm up and it is less dense than the cold air, so it will rise. Once it rises, it will push other air out of the way and back towards the ice cube, and the process will repeat. Finally, a couple of examples of convection in action. So we have a building here, and inside that building, if it has a radiator, what will happen is the hot air will rise and the cold air will sink. However, if there are any gaps, the hot air will be able to escape. Meanwhile, cold air will be able to enter that room. This is why it's important to prevent drafts. We also have something called convection currents in the mantle of the Earth. In this case, because the core of the Earth is a significantly higher temperature than the surface, the core of the Earth heats the mantle around it. Those rocks become less dense and gradually drift upwards. As they do so, they cool down, and then they begin to sink back down again. This is what causes the tectonic plates on the Earth to move. They are being dragged along by the fact that the mantle is gradually moving.